Section 6.3 is dealing with polynomial functions. A polynomial is written in standard form when the values of the exponents are in descending order, meaning the highest exponent first, and sometimes you might have to fill in any missing zeros if you have any missing zeros. The coefficient of the first term is called the leading coefficient. So the very first polynomial is a constant, which is 12. That's a constant function. What kind of line is that? It's a horizontal line, isn't it? And there is no variable, so what is the degree? 0, and the leading coefficient is 12. We have a linear. An example of a linear is 4x minus 9. The degree is 1, and the leading coefficient is the number in front of x, which is 4. So the third one is a quadratic, 5x squared minus 6x minus 9. What is the degree here? 2. And what is the leading coefficient? 5. A cubic function has 8x cubed. Here's an example. 8x cubed plus 12x squared minus 3x plus 1. What is the degree here? 3. And the leading coefficient is 8. Now, after the function after x cubed, there's no special name for any of these polynomials. They're just general polynomials. For example, the last one, what is the degree of the last one? 4. And what is the leading coefficient? 4. Also 4. When we're talking about descending order and leading coefficients, they're all variables in one term, meaning one variable. If you have more than one variable, we would not talk about those. Those would not be a polynomial in one variable. Example 1, state the degree and the leading coefficient. So the very first, always look to make sure that it is in descending order, which is called standard form. And it is example A in descending order. Yes, it is. So what is the degree? 5. The degree is 5. And the leading coefficient, by the way, the abbreviation for leading coefficient is capital LC. So the leading coefficient is 8. Look at example B. Because we have two variables, it is not a polynomial in one variable. Now let's look at example C. Is this in descending order? No. So we have to rewrite it and put it in descending order. So when we rewrite it, it'll be negative 4x to the 8th plus 3x to the 4th plus 6x to the 3rd plus 2x. So we're going to put it in descending order. Now, what is the degree in this polynomial? 8. And the leading coefficient is negative 4. Very good. Example 3a. We're going to find the function of 3c minus 4 minus 5 times the function of c. Now this is can be a little tricky. This function, the F stands for function. Okay, these are called function values of variable. They're a little bit more complicated. We've got multiple steps. The very first thing we're going to do is we are going to find the function of 3c minus 4. Meaning, wherever we see x into our function, what are we going to replace x with? 3c minus 4. So the very first thing I'm going to do is I'm going to write the function down again. And I am going to find the function of 3c minus 4. So wherever I see x, I am going to plug in 3c minus 4. So everyone do that. Okay, so wherever we see x, I'm going to plug in 3c minus 4. So that's 3c minus 4 quantity squared plus 2 times 3c minus 4 minus 3. Okay, now we talked a little bit about a binomial square. What does that binomial square mean? It means two binomials. What we're going to do is I'm going to go to the side and do side work. And so I want you all to do that in your margin as well. Okay, so I'm going to go to 3c minus 4 quantity squared. So we're just going to zoom in and look at that. 3c minus 4 squared. There's a shortcut, and there's the long version. I'm going to show you the shortcut in a minute, but I'm going to do the long version. That means it's 3c minus 4 times 3c minus 4. And we know how to multiply two binomials together. We do the FOIL method. So let's everybody do the FOIL method. 3c times 3c is 9c squared. My outside term is a negative 12c. My inside term is a negative 12c. And my last, negative 4 times a negative 4 is a positive 16. We bring down the first term. Look at our two middle terms. What are they? They are identical. They're always going to be identical when you multiply two identical binomials. So we get negative 24c. And then bring down the plus 16. Okay. Now, some of you might have remembered learning this in Algebra 1. Some of you might not. But I'm going to show you the shortcut. As soon as you learn the shortcut, it's going to help you. If not, then you need to go to the side and do the long version. The shortcut is square the first term. So what is the first term squared? 9c squared. The second term, multiply these two together, the first term and the last term, and make sure that sign, that's in a negative 4. So what is 3c times a negative 4? Negative 12c, and then we double it. Double means add it again, add it twice. So what is negative 3c minus 4? That's a negative 12. Doubled is negative 24c. See, that's why these two are identical over here. And then square the last term is a positive 16. So let's go back to the other panel. So right here, 3c minus 4 quantity squared. Let's do the shortcut again. We square the first term, 9c squared. Multiply these two together. That's a negative 12c. Double it. Say negative 24c. And then square the last term. That's a positive 16. Then the second step, we're going to do the distributive property and get positive 6c and a negative 8. Bring down the minus 3. Now we need to clean this up a little bit. Do I have anything to combine the 9c squared with? No. Negative 24c and a positive 6c is a negative 18c. And then combine 16 minus 8 is 8. 8 minus 3 is 5. So that is the part 1. I'm going to box it so that I know that is a part 1. That's doing the f of 3c minus 4. Part 2 is I am going to multiply 5 times the function of c. Now, I know there's a minus sign out there. I'm going to ignore that minus sign for just a minute. So now, into this function, I have to first multiply a 5, and then wherever I see x, what am I going to plug in for x? A c. I'm going to do function of c. So I have to multiply 5 times that entire function. So I'm going to put a 5, and then I'm going to put the entire function inside a bracket. All of this inside a bracket. And wherever I see x, what am I going to plug in? C. So that'll be c squared plus 2c minus 3. Now, could I put a parentheses instead of a bracket? that's fine. Bracket, it means the same thing as parentheses. So I'm going to now distribute the 5 out. So I get 5c squared plus 10c minus 3. So that is the function of 5 times the function of c. So that's this part right here. Now look at the two functions. What am I doing to the two functions? I am subtracting them. So the very first function, so basically I'm subtracting these two boxes. Now I'm going to rewrite it, and instead of the box, they're going to be polynomials, they're going to be in parentheses. So 9c squared minus 18c plus 5 minus, so I put minus, the 5 times the f of c is 5c squared plus 10c minus 3. Now, when you have two polynomials that you are subtracting, the very first polynomial, we drop the parentheses and rewrite it as is. And what happens when we have a minus sign in front of the parentheses? We distribute the negative. So that's negative 5c squared minus 10c plus 3. Combine, and then we're ready to combine like terms. 9c squared is 4c squared minus negative 18c, and a negative 10c is a negative 28c. And then 5 plus 3 is 8. Okay, I messed up right here. That should be a 15. I forgot to distribute the 5 times everything, so it should be 15 right here. It's plus 15. Now 15 plus 5 is 20. And this is my final answer. So there were 3 steps, 3 main things we had to do. Let's do another one. So the very first thing we're going to have to do into the function, the g of x is the same thing as f of x. In the function, in the g of x function, wherever we see x, what are we going to replace? We're going to, right, everywhere we see x, we're going to plug in 5a minus 2. So let's first write the function. G of x is equal to x squared minus 5x plus 8. So we are first going to do step 1, g of 5a minus 2. That means wherever we see x, we are going to plug in 5a minus 2. So 5a minus 2, quantity squared, minus 5 times 5a minus 2 plus 8. We have 5a minus 2 quantity squared. Let's try to do the shortcut. Square the first term is what? 25a squared. Multiply these two together, negative 10a, and we double it to give negative 20a. And then square the last term and we get positive 4. Now we're going to do the distributive property and get negative 25a plus 10 plus 8. Combine like terms. I don't have anything to combine the 25a squared with. Negative 20a and a negative 25a is a negative 45a. 4 plus 10 plus 8 is 22. Now, just to help my eyes, I'm going to box that. That is the part 1 where we plug in 5a minus 2. Now we're going to do the second part. We're going to do 3 times the function. Okay, now I'm going to work inside the bracket. So that's 4a squared minus 10a plus 8. Now I distribute and get 12a squared minus 30a plus 24. I'm going to go ahead and box that Now, what do I do with these two boxes? Go back up to the problem. I am going to do what? What operation is this right here? Add them. Now, when I'm adding these two polynomials, I could put them in parentheses and put a plus sign in between. And then the next step is dropping the parentheses, and does it change anything? So could I just go directly to putting them all in one line without the parentheses? And then combine like terms. 25a squared and a 12a squared is 37a squared. Negative 45a and a negative 30a is a negative 75a. 22 plus 44, 22 plus 24 is 46. Okay, y'all do this one. Okay, check to make sure you have the first part. And then do the second part. 2d squared plus 5d plus 3. So we distribute 0.5 times 2 is 1d squared, or could we just say d squared? Okay, did y'all get all that? So, when you go to do your homework, should you try doing these examples first? Yeah. Yes. Check your answer in the back of the book. The bad part about the answer in the back of the book is it just gives you the final answer. It doesn't give you all the steps in between, so if you get it wrong, you have no idea what you did wrong.
Well, normally the reading section will have
Yeah, I think the homework that has the problem that has like a star or something, that means it gives you the steps.
Yeah, like circles it.
Circles it, yeah. Okay, let's look at example 4, and we're going to determine some things. What is the leading coefficient?
1, negative 1.
The leading coefficient is negative 1. So does the right end go down or up?
Down.
The right end is down. Is it an even exponent or the degree? Is it an even exponent or an odd? It's an odd degree, so what does that mean?
Their ends are going to be opposite.
Their ends are opposite. Now we can kind of get a visualization. And how many zeros do we have?
They're going to be
5. That means it's going to cross the x-axis 5 times. And I know that the right end is going down, so I know it's going to end like this. And are opposite, so the left is going to be what? Up. So it's going to look something like this, and it's going to cross 1, 2, 3, 4, 1, 2, 3, 4, 5, something like that.
Won't there just be up to 5? Like, not necessarily.
Okay, and this is like your homework, where you're going to have to list 3 things. You're going to have to state the end behavior. Now, again, the end behavior is going to look different from your back of the book, the key. You're going to look at my key. I will tell you, okay? Now, number 2 is tell if it's an odd or an even degree, and number of zeros. So what is the end behavior? For example, the end behavior, the leading coefficient is what? Positive, because the end behavior is going up. So the leading coefficient is positive. The end behavior, you can say right end to up.
And then it's even.
So the right end is up, so the leading coefficient is positive. Why does it? the exponent is odd. It could be 3, could be 5, could be 7. Because you could have imaginary numbers too. So that's why, I mean, I'm thinking it would be 3, but not necessarily.
Right, you could get some nerves.
Yes. Now, make sure that you bring a graphing calculator to class next period.